Good morning, everybody, or good afternoon if you are a late sleeper. We're going to be working on more right triangle stuff today. In general, the quizzes were very good from yesterday, so nice job on those. If your grade's not up, it will be up today. I had a couple of late submissions after I went to bed last night, so I have to do those after I post this video and the work for today. All right, so what are we doing today? We are starting right triangle trigonometry. This is probably my favorite part of geometry. Right triangle trig is so cool, and it's a skill that's really important because you are going to use it for the rest of your math classes. Whether you take Algebra 2 next year, Modern Math, AAT, if you end up taking pre-calc at some point, okay? Whether you take math classes now or in college, you will use right triangle trig. And it's very applicable. You can solve a lot of really cool word problems with it. I love this section of our lesson. So we're going to be taking it slow. Today we're just going to kind of dabble in the world of what is trigonometry. We're going to identify key parts in right triangles. Okay, so that's our main goal today, is to identify those key parts in right triangles. All right, because we've got all different key parts that we need to talk about. And we're also going to start setting up our trigonometric ratios. Now, that sounds like a foreign language right now, but once we get into it, you will see it is really not that bad. You're going to have a lot of new vocab words today. You're going to hear a lot of phrases you've never heard before. So, if you have a question, make sure you email me. You could post it directly on this assignment tab because you will be hearing some new things today. When you guys have a question, if you hit a point in the video and you're not understanding something I'm talking about, when you email me that you're a little lost, make sure you tell me what time of the video you're confused about. That way I have a reference point I could go on and I can try to help you from there. Hopefully you won't need it today, though. All right, with that being said, let's get started. Okay, so make sure you fill out your notes as you're following along with our stuff here. Let me do this sideways so I have some more room. Okay, so first of all, what is trigonometry? I'm thinking you guys may have heard this word before. If you didn't, well, now you have. Trigonometry is the branch of mathematics that deals with relations and sides, relationships of the sides and angles of triangles. And then eventually with the relevant functions of any angle. So if you get into pre-calc, you'll do an entire unit on just trigonometry without only right triangles. So we're really just dabbling in this world of trigonometry. There's a whole world of trig. We're only working specifically with right triangles today, okay? All right, so parts of every right triangle. Now, you guys don't have this on your notes, so make sure you fill this out because this is the guided section, okay? All right. So we have the right angle, which that's nothing new. You guys have done right angles before. It's the 90-degree angle, but something important to note is that it is never going to be what we call the reference angle. Okay, so this is our right angle right here. The reference angle, some of you guys might be like, what's a reference angle? The reference angle is the angle we're using as our starting point to label the sides of the triangle. So a lot of times your reference angle will be labeled with a capital letter like A, B, X, Y, Z. It could be anything. But every once in a while, you'll see this little symbol that looks something like that. It kind of looks like a curly QO, okay? Let me make that a little bit clearer so you guys can see it. It looks exactly like a little O with a curly Q through it. Now, you might be thinking, what the heck is that symbol? What does that mean? Okay, that's actually, I can't even draw it right. That's actually a Greek letter, all right? And it's called theta, okay? So this guy is a Greek letter. And it's called theta. And just like how we use X a lot of the time, find the missing side, find X, find X, find X. Trigonometry is literally a Greek word. So a lot of the variables that are used in upper levels of math are actually Greek letters. And theta is kind of like the Greek version of our X. We solve for the missing X lot. It's just a variable. It's just the missing angle. It's an unknown, okay? It represents an unknown, okay? And we're going to say angle because it almost every time has to do with an angle. So anyway, the reason I went off on that tangent is because a lot of times theta will be used, to represent your reference angle. Okay, so that would be our reference angle in this case. Now, we could use either of the acute angles as our reference angle, okay? So it could be this angle that we just labeled as theta, or we could also use this angle up here as the reference angle. I'm just going to call that, we'll call it angle A for right now. Okay, either one of those could be used as our reference angle, but we cannot use 90 degrees as the reference angle. That's really important to note, and you guys will see why in a little bit. All right, so next we've got the hypotenuse, which we know is always the side that's across from the right angle. Okay, the hypotenuse is always the side across from the right angle. All right, so this would be my hypotenuse. All right, then we have something called the opposite leg. And that opposite leg is going to be exactly how it sounds. It's going to be the side across from the reference angle. So if theta right here is my reference angle, the side across from it is my opposite leg. So then we could label this as the opposite. And it's across from the reference angle. And then last but not least, we have the adjacent leg, which is the side next to the reference angle, but it can't be the hypotenuse. So again, if this is our reference angle right here, angle theta, we already have our hypotenuse labeled, so this side that's next to it has to be our adjacent side. And we can label this as adjacent, okay? All right, so this seems kind of silly, but this is actually super important, and I find a lot of times kids make a mistake in labeling the opposite, the adjacent, and the hypotenuse. And if you make a mistake in labeling these sides, it's going to screw up the rest of your problem. So it's really important to make sure that you are able to label them. So here's an example. Labeling your sides. Label your sides using angle A as the reference angle. So here's what I like to do. I like to circle my reference angle. So I know, all right, this is what I'm doing everything in reference to. All of my sides are based off of this angle. Then I like to label my opposite side right away. So the side that's opposite from my reference angle is going to be side BC. So this would be my opposite. Then I like to label my hypotenuse because that's always across from the right angle. So I can label my hypotenuse. And then last but not least, we have the adjacent, okay? So now let's see what happens when we switch what our reference angle is. So remember, we said before that angle B can't be the reference angle. Okay, but we could switch it and we could make the other acute angle, which is angle C, that could be our reference angle. All right, let me just turn this here. Okay, so we're going to do just that. Let's label our sides again, but we're going to use C as the reference angle. So let me circle my reference angle. Immediately, I'm going to label my opposite. And then I'm going to label my hypotenuse, which is right across from the right angle. And then I'm going to label my adjacent, which is right next to my reference angle. So here's the grand question of the day. Why can't we use B, which is our right angle, as our reference angle? What happens when we try to label the diagram? So we can't use the right angle as our reference angle because the reference angle must be acute. And here's why. When we try to label it, let's see what happens. So I'm going to circle this, and I'm going to label my opposite. But then you might be seeing the problem now. The opposite is also the hypotenuse, and then we have two adjacents, and that just doesn't make any sense at all. Okay, so our opposite would be the same as the hypotenuse. And we would have two legs, or we have two adjacents, sorry. So if you ever run into a problem in labeling your triangle, check to make sure that you're not doing something silly like labeling or using the right angle as your reference angle. Okay, so all pretty standard up to this point, but now we're going to dive into a phrase that is now going to be your best phrase, your best friend forever and ever. You're going to use this phrase all the time. It sounds completely ridiculous, but it's just a mnemonic device to help you remember a lot of our trig stuff. So your new favorite phrase is right here, and your new favorite phrase is this crazy, crazy word. Let's see if I can find a new color here. It's this crazy, crazy word called SOHCAHTOA. Okay, so say it with me. SOHCAHTOA. SOHCAHTOA. Okay, now SOHCAHTOA, like I said before, it's just a mnemonic device to help you remember the different trig ratios. So we have 3 trigonometric ratios, and what the ratios are going to do is they're going to relate our sides together. Okay, so we have the sine ratio. Whoops. We have the sine ratio. We have the cosine ratio. And last but not least, we have the tangent ratio. Okay. So let's kind of break all these down here. Sine, cosine, tangent. So SOHCAHTOA, like I said before, is a mnemonic device to help you remember these different things. Now, it says that the sine ratio is the ratio of the leg opposite of the angle to the hypotenuse. Okay? So sine is opposite over hypotenuse. Okay? Now, for all of these problems, we're just going to use angle C as our reference angle for the time being. Okay, this is our reference angle. So, this would be my opposite, this would be my hypotenuse, and BC would be my adjacent. Okay, so sine of angle C is equal to my opposite, which is AB, over my hypotenuse, which is AC. Okay, actually, you know what? I'll write that down here so it doesn't overlap. So sine of angle C is equal to my opposite, which is AB, over my hypotenuse, which is AC. Okay, so this is the setup every time you use your trig function, and we have, you don't have to write out the entire word. Sine is represented with SIN, cosine is represented with TOS, and tangent is represented with TAN. Okay, so you put the shortened version of the trig function, and then you put the reference angle in parentheses, and then you write whatever the two sides are. Okay, so in this case, we had opposite and we had adjacent. Okay, so this one was opposite over hypotenuse. All right, so next, we've got cosine which is the ratio of the adjacent leg to the hypotenuse. Okay, so we're again using reference angle C, and cosine, cosine is the adjacent over the hypotenuse. So cosine of C is equal to the adjacent side, which is BC, over the hypotenuse, which is AC. Okay? And then last but not least, we've got tangent, which is the opposite side over the adjacent side. So we have tangent is opposite over adjacent. So tangent of C would be equal to the opposite side, which is AB, over the adjacent side, which is BC. Okay? So again, that's where SOHCAHTOA comes from. It's just a mnemonic device. It's not an actual word. It's just a phrase that we use to help us remember the ratios that you should be setting up for your three trig functions. So again, just to recap, sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. Okay? Okay. So we are going to use that triangle above, and we are going to write three trigonometric ratios using angle A as our reference angle. Three trig ratios using A as our reference angle. All right, so we just used angle C as our reference angle. So now we're going to be using angle A. Now let me just redraw this real quick so that we can use it as a reference. So we've got our little diagram to go off of. All right, it's not perfect, but it looked something like this. And this was angle B, this was angle A, and then down here we had angle C. So again, in this example, we're switching it up because we are going to be using angle A as our reference angle. So again, that's how I like to do it. Circle the reference angle, highlight the reference angle, whatever you need to do, and then label your sides. So this is my opposite, this is my hypotenuse, this would be my adjacent. Okay, also write down SOHCAHTOA every single time. Okay, and these are supposed to be fractions. If it's not that clear, let me just fix that for you. Okay, so you should be writing down SOHCAHTOA every single time until you know it by heart, until you're having dreams about it. You should be writing it down. SOHCAHTOA, right? So let's write our three ratios out. So let's do our sine first. Sine of angle A is equal to the opposite over the hypotenuse, so it would be BC over AC. Cosine of angle A is the adjacent over the hypotenuse, which is AB over AC. And then I'm just going to put my last one here. Tangent of angle A is the opposite, which is BC, over the adjacent, which is AB. Okay. Now, example, write three trigonometric ratios using angle B as your reference angle. We cannot. Angle B is a right angle. Okay, so we wouldn't be able to use that as our reference angle. Okay. All right, so here's a couple of examples, and then I'll send you guys on your merry way. So now, instead of just having letters, we have numbers. All right, so I'm going to do all of my A's in red, and my B's are going to be in blue, just so we can, angle C is going to be in blue, just so we can see the difference. Okay, so angle A. So here's my reference angle for my first one, and now I'm going to label my opposite, my hypotenuse, and my adjacent. So sine of A is opposite over hypotenuse. Adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. So sine of A, opposite over hypotenuse, would be 5 over 13. Cosine of A would be adjacent over hypotenuse, which is 12 over 13. And tan of A would be opposite over adjacent, which is 5 over 12. Now we're going to flip things around a little bit, and we're going to use angle C as our reference angle. So you'll notice the hypotenuse is still the hypotenuse, but what happens when we switch the reference angle is that the opposite and the adjacent sides switch, okay? So sine of C is now going to be 12 over 13. Cosine of C is going to be 5 over 13. And tangent of C is going to be 12 over 5. All right? So since we switched the opposite and the adjacent, these two did a little flip-flop. And then this one switched the numerator and denominator. Okay. So I want you guys to pause the video and try numbers 2 and 3 and then come back and check your work. I'll give you a hint for 2 and 3. Make sure you simplify the fractions. So you could pause the video and then come back and check your work. All right, another hint here, because as I started to do the answers, I realized you might be stuck a little bit. We don't have the length of WX, which is the hypotenuse in this case. So think back to what we just did with right triangles. If I know 2 out of 3 sides in a right triangle, I can use Pythagorean theorem to find the last missing side. So I can set up 9 squared plus 12 squared equals my hypotenuse squared. Okay, I end up getting, what is 9 squared plus 12 squared? 225 is equal to c squared, and then the square root of that would be 15. So the length of my hypotenuse is 15. Okay, so now pause again and finish the trig ratios. All right, so hopefully you guys are checking your work now and you're finding that you got the correct answers. So again, for problem number 2, we needed to have the length of WX, so we used Pythagorean theorem to find that missing side, and we get 15. Then we just set up our trig ratios. Now, it's kind of hard to look at this all at one time, so it's best if you just work with one angle first, and then either erase your work or go to a separate color or a separate sheet of paper and do the next one. But sine of W, we end up getting our opposite, which is 12 over 15, and that reduces to 4 over 5. Cosine would be 9 over 15, which reduces to 3 over 5. And then tangent would be 12 over 9, which reduces to 4/3. And then with sine of x, we just switch our reference angle. So our opposite over hypotenuse would now be 9 over 15. Our adjacent would be 12 over 15. And tangent would be 9 over 12. And then for problem number 3, it was the same type of idea. You needed to use Pythagorean theorem to find that last missing side. Now, in this case, we weren't finding the hypotenuse. We were finding a leg. So make sure when you set up Pythagorean theorem, you set it up correctly, and you did 16 squared plus either b squared or a squared equals 34 squared, because that was the hypotenuse. And then you just go through and you set up all the same ratios. Okay? All right, so that was trig, ladies and gentlemen. What I'm going to do is I'm going to post a Google form that I want you to work on, submit it, and I'm also going to post some additional practice problems. If you have time, you can do them. If you don't have time, don't panic too much about it. But I just want to make sure that you guys are really ready to go in setting up these trig ratios, because we're going to need them for our next couple of lessons, and you need to be really good at it. Okay? As always, if you guys have any questions, just reach out via email or comment directly on the post, and I will chat with you guys soon. Have a good day.